So in this unit, we've been focusing on balanced forces, which give rise to constant velocity motion, and vice versa. And we've mainly focused on a single object at a time, or, more recently, on a system of objects, right? And what forces act on those objects, and drawn force diagrams and the like. But I want to take a step back here and think about how we originally defined a force. Right? We defined forces as interactions between two objects that resulted in pushes or pulls. Right? And we spent a lot of time drawing system schema that showed those interactions. But once we started drawing force diagrams, we kind of left those interactions aside. Right? And we might have talked about, for example, a surface supporting you with a normal force, but we didn't really talk about what then do you do to the surface. Right? We only talked about half the interaction. Well, we're going to do some investigations here to help us discover Newton's third law of motion. And Newton's third law of motion deals with those interaction forces that exist, with both sides of it. The floor supporting you, and you doing something to the floor. Right? So we're going to look at that here in a little lab, a couple of labs actually. So for example, if we had two carts and they collided, we might look at the forces that occurred that one cart put on the other cart and back, right? That the green put on the yellow and the yellow put on the green, and compare them and see how did the magnitude of those forces compare and how do the directions of those forces compare, right? When they're interacting. So we're going to set up some situations so that we can see both ends of the forces. Now, traditionally, we'd actually do a lab like this with carts and force probes and use the computer to measure the forces and things like that. But this being 2020, we're going to have to do something online as we're all online now. And so we're going to use a new program which is called Pivot Interactives. Those of you that have been fully remote have done a few Pivot Interactives at this point. Right? Those of you that have been in class, this will be your first one. So what is a Pivot Interactive, you ask? Well, basically it's an interactive video lab. Right? And you'll see as we go in that some people that put together this program have taken some very high-end videos of physics phenomenon, videos that are often done at very high speed, right, and very focused in, and they're also done with equipment that we can use inside of the video to make measurements. So we can actually measure data of real things, right, that have been videoed. So it's not as good maybe as doing the lab and actually seeing it, in real life, but it's about as close as we can get. It's a pretty good substitute, about the best substitute I've ever seen for doing a lab when we can't really be in class and hands-on. So we're going to do a bunch of pivot interactives as we go throughout the year, right, until we're back in class. Now, in order to do Pivot Interactives, kind of like the Concept Builder program, you have to register first. Right? If you go to your schedule page, right, your schedule doc on Google Classroom, there is a link. This paragraph exists on there, all right, and it tells you to go to this link, and then this document, which I'm going to pull up here in a minute, is always under classwork, under the lab help topic, so that you can use it again if you need to. So if I click on this, you'll be able to get this link on your doc. It looks kind of like this. You'll see that just like with the concept builders and Google Classroom for that matter, each hour has its own class key. Please make sure you register in the correct hour so that you show up in the correct place when I use the program to grade your labs. It gives you links to go to Pivot Interactives. That's also on your schedule doc. It shows you how to do it, to put in your class keys. Right? When it asks you, please use your actual first and last name so that I know who you are. Use your school email. You have to put in your email, but please put in your Gmail from school so that I have that as well, and so that we are all set up with the school. You have to make and confirm a password. It can be whatever you want it to be, but you have to remember it. Once you do that, it'll take you to a page which will allow you to choose which activities you want to do. You'll see some on there that are actually old. The fully remote students have done those activities already, but they're not for you. You've already done the labs in class, but you'll see a couple that we're going to do today. So please go back and fill in or follow this document and register with Pivot Interactives. Right? Once you register once, all you'll have to do is go to Pivot Interactives, log in, and away you'll go. Now, in this case, like I said, we're trying to figure out how the magnitudes and the directions of the forces of two interacting objects compare to one another, right, when they're interacting. So to do that, we're going to do a couple of pivots. The first one is called forces of interaction during collisions. The second one is called dueling force scales, tug of war. And so I want to show you at least the first pivot and show you some little things inside of it to help you out a little bit. Okay? Everything I'm going to do are instructions, which are inside the pivot and on the lab sheet which can, of course, be found on the schedule doc. So let me show you this. So once you log in and you choose the activity, you'll see something that looks like this. Right? This is forces of interactions during collisions. Here's our learning objective, our purpose, if you will. And the first thing is just a video which is going to show you how the equipment works. This is actually two gliders on an air track. It's kind of cool. And these little rings of metal, right, which are going to deflect when they run into one another. But you can watch that video later. Okay. Then this is the video that you're going to use to actually figure out what's going on, to see the interactions, if you will. Okay. It's a nice high-speed video, I think 60 frames per second, so lots of video there. This next little part shows you the steps, all right? Tells you what I want you to do. This is also, all of this is also on the lab sheet, okay? Once you finish the lab sheet and you've done the whole lab, right, then you can go and answer these multiple choice questions. You'll know whether or not you got them right. There's feedback if you don't, and if you do. Right? And then once you finish that, you'll go on to the next one. So let me show you kind of what I'm talking about here. And again, these steps are also on the lab sheet. So this first button over here, down here, right, is to make it bigger, which might help, right, so it's full screen. That's especially true if you're trying to do this on your phone or something like that, right, which will get difficult. So first off, if you just hit play, right, you can see the two gliders running into one another, and for some reason they show it twice every single time. Okay. Once you're in there, okay, you can move this slider around. You can use the buttons to go frame by frame. We can use the arrow keys. I'm hitting the arrow keys on my laptop right now, right, to go frame by frame as well, which you might find easier. And you want to find that perfect frame that looks good, where the carts are interacting with one another. I like to use maybe maximum deflection, or as much as I can see there. And then the question is, well, if these wire rings are the same, and they are, then the amount that they're deflected or bent, if you will, should be related to how much force they're exerting, right? The more they're deflected, it's kind of like a spring, right? The more they're going to push. So, you could just eyeball it, but there is a handy little thing. Up here, this is called the Tools button. Very useful in these. And if you hit that, it gives you a couple of tools. One is a stopwatch. If you click on that, a stopwatch will pop up. Notice if I go frame by frame, right, it changes the time, and it tells me what frame I'm in, and it tells me how fast everything is running. But that's not very useful in this lab. Might be in other labs when we need a time. Right? So I can turn that back off. But this is the one that's going to be useful. This one is a horizontal ruler. When you click on it, see, there's the ruler. You can click on it. You can drag it around. You see where the 0 is, right in the middle. So it says in the instructions to get the frame that you want here, you know, maximum compression or something close to it. And then take this and put the 0 right on the interaction. Try to position the 0 right on top of the interaction, as close as you can get it. And then you can measure how much each one is deflected. If you go a different frame, you got to move this around, right? And it'll live there the entire time you're doing the lab. Okay? So you might look at this. I don't actually want you to write down numbers. I just want you to compare. So this is 5, 10, 15, about 16. This is 5, 10, 15, about 16. So it looks to be the same. On your lab sheet, there's 3 boxes, and you're just going to check the one that applies. There's one that says right is equal to left. There's one that says right is greater than left, and there's one that says right is less than left. So in this case, you would just put a little X or a check mark in the equal one. And then you're going to change the situation. How can you change the situation? Right down here, this is the parameters bar, and there's 4 different parameters. You can change the size of the right mass, you can change the size of the left mass, you can change the right speed, you can change the left speed. You can get to the choices by clicking on them, or you can hit change, and all these pop up. Right? So you can make any combination of these things. Right? Whatever you want. Maybe you want a heavy right mass and a heavy left mass, and you want the right one to go slow, and you want the left one to go fast. Now, you do have to hit load. When you're done choosing your parameters, you have to hit load. And what happens is, see, it's loading a new video. And in this video now, the right mass is heavy. See, they put a mass on it. The left mass is also heavy. They've each got masses on it. The right speed is going to be slow, and the left speed is going to be fast. So now if you play this video, see, one went slow, one went fast. And I'll do it again. Slow, one went fast. And you can do the same thing, find where you want it. You can look at the first or the second one, right, and compare the deflections. And then change something and do it again. That is this lab. Okay? Remember that you do have to move this one around so that it's always right on top whenever you decide what frame you want to use. Right? If you're not sure if it's equal or if one is bigger than the other, you might look at the other collision, right, that's in the same clip, or you might move a few frames, right, and check that one, see how it compares, so that you can convince themselves, you know, if they're equal or vastly different or however you want to do it, right? So that's how you do a pivot interactive, or at least a very basic one. Okay? The second one just has a couple of spring scales that are playing tug of war. I think that one's a little more straightforward, especially after you've done this. So hopefully you can follow the instructions in there and answer those questions as well. And then you will learn about Newton's third law.